Good afternoon to everyone, and welcome to webinar series organized by International Collaboration Centre of ULS University Sri Lanka with the collaboration of Audiovisual Unit of Sri Lanka. I think I'm audible to you. Navoda, am I audible?
Yes, I can hear you very well.
Very good. So greetings to all. Now we are going to start the third webinar of this series. Today's webinar is on the topic resource and energy efficiency. So I would like to welcome, today we have two resource persons. First of all, I would like to invite Mr. Navoda Senanayake, proud product of ULS University. Now he is currently project manager of energy and climate at International Project Management Institute for Applied Material Flow Management in Germany. Also, I would like to welcome Mr. Christoph Dohm, Project Manager, Energy Efficiency and Renewable Energies from Institute for Applied Material Flow Management in Germany. So both are welcome to ULS University. Hi all, Mr. Chris, Mr. Navoda. Good afternoon to all.
Good afternoon to everyone.
Right. So our aim is to our aim is to the idea behind organizing this webinar series is since we are a young university, the 14th national university in Sri Lanka. So, but we have produced so far last 15 years we have produced many graduates as well as professionals, and we see that many of our graduates nowadays working in foreign countries as well as they are studying for their PhDs. So we thought that in this pandemic situation, since we all are using technology and we get connected via a platform like this one, Zoom. So we thought that we can get together in a online session like this, like a webinar. So we organized this session to bring insights of these professionals and academics to make a discussion online to have a discourse on selected topic. So with that aim, today we organized this webinar under the title Resources and Energy Efficiency. So since I am not directly from this material flow management subject, I would like to hand over the session to our proud product of ULS University, Mr. Navoda Senanayake, because I see that he has become expert in this field. So Mr. Navoda, I would like to initially invite you to start this webinar. Over to you, Navoda.
Yes. Yeah, thank you. Thank you very much, sir. Yeah, so I will share my screen now. I hope it's visible, right?
Recording in progress.
Yes, it's visible.
Yeah, okay. So first of all, thank you for arranging this kind of event. And it's a great honor for me to invite for the session. And thank you very much for that. So first of all, as Jagat informed that I was a student in mineral resources and technology in 2010 batch. And then I used to work in Sri Lanka for 2 years. And then I moved to Germany by applying a scholarship. So since then I'm here and I finished my master's 1 year ago, 1.5 years ago, and then I started working as a full-time employee for the Institute for Applied Material Flow Management. So today, as Mr. Jagat told, that Christoph Dohm, one of my friends and colleague in the department, he's also joining with us. So we'll move to the outline. So to be honest, we have a lot of things to talk about, but unfortunately we have limited time. So I hope to give you an exposure other than giving you definitions, calculations, methods, and so and so. So because those things, all of you, of course, you can find them in internet. There are millions of resources for you to find. So my idea today is to give you an exposure about what we do, how we do, and how I made the link from mineral processing technology all the way to material flow management, and what I am doing at the moment in Sri Lanka and other countries as well. So, and in the last topic, I would like to talk a little bit about my PhD topic. It is one of my own topics, and I'm planning to give you an idea about that, because already I'm working with Wellas University at the moment. 2 students are doing 2 subtopics of my PhD topic, and they are already finished and they are in the final phase of submitting. So after I give a basic introduction, my friend Christoph will talk about one of his expertise area, and then we in the 2 megawatt capacity, and because recently we built several car parks in here as well. So the university is actually a living or a functional model to show to the outer world that it is possible that we can run from renewable energy. Of course, there are some problems in terms of managing the load and balancing the load and the energy density and the energy efficiency and the supply of energy to different places. So there are certain problems, but in proper planning and in proper financial modeling, these things can be avoided. So this is a living and functioning model in Germany, and we are getting 100% renewable heat supply from a nearby power plant, a cogeneration plant, and I have a slide on that as well. And as you can see, we are powered by PV energy for the electricity consumption. We are actually going the net zero balance, because in the daytime we are creating more than enough, and in the night we are using from the grid and the excess amount that we supply to the grid. So the idea of this university is actually we are a small part of a big university, and we are functioning as an individual university. The main university is known as the University of Applied Sciences Trier. So it is a little bit away from our campus, and we are located in like 2 hours away from Frankfurt, towards France border. It's a small village, nice place. You can see it's most of the agricultural aspects are based on this area, and it's also an industrial zone where we live. And this part of the campus, they are all student dormitories, and at the moment I'm sitting here. I'm sitting in this building. We both are sitting in there, and yeah, it's a nice place. Every year we have a conference called Circular Economy Week, and we are bringing like 1 or 2 Sri Lankans every year, maybe secretaries from ministries, vice chancellors, and like that. So I'm planning it to introduce to our university as well, to bring some resource person from our university, Wellas University, to this and give an exposure. And last year and this year it's not going to happen because of the pandemic, but let's see in the future. And as we told, according to the green metrics, we are number 6 globally, and in 2020, and it's more or less same as Wellas University. It's not that much big. We have nearly 2,500 students, including master students, and also there are around 50 PhD students, including me. I'm actually doing my own topic, but there are some students who are working for some of the projects we are doing with the industries and some of the companies. So Ifas is an institute based inside the campus. We are known as Institute for Applied Material Flow Management, and it is the English term, and the German term is the Institute for Angewandtes Stoffto Management. So it is founded in 2001, and we are operating as a non-profit institute. We have nearly 9 professors and 80 employees, actually 100 employees, including full-time employees like me and some of the research assistants and student assistants. So what we do mainly sustainable development projects, circular economy practices, and promoting these things to communities, municipalities, companies, countries, and we are all focusing on the environmental aspects of all those projects. And I'm specialized in environment, energy and climate. So whatever the projects we are doing, I'm responsible in calculating energy and carbon balances and so and so. So we have a team, we have an interdisciplinary team starting from engineers, ecologists, economists, and a wide range of expertise and resource persons are inside the campus. So also we have some other institutes which are based in the campus, and we are working with them as well. So that is basically about us and why we are doing this. So we know that the climate change is a big problem nowadays, and in Sri Lanka, it's sad to say that no one is actually, there are a few people, but it's not a big topic in Sri Lanka. But because we don't have carbon taxes and we don't have any problems in that area in terms of policy wise, and we have signed for the Paris Agreement and we have the nationally determined contribution set of that like that, but we are not contributing to these things. So it is no matter that where I'm based on the world, I can be in Germany or in South Africa or wherever, the amount that I make as a negative impact to the earth should not be the case. So greenhouse gas emissions, global warming are some interconnected things, and people are talking about oil peak, the crude oil peak, and I'm not that much concerned on that because I used to do my internship in Petroleum Resources Development Secretariat in Sri Lanka, and at that time I understood it is not that much a big problem. We have different technology to reach to the deepest points of the earth and they extract whatever we can. But if you take a look on the carbon budget, it is around, we have the carbon budget until nearly for another 20 years, maximum 17, 20 years. So in that time period, we have to do the transformation to become zero emission, the whole world. So we are running out of time, and it is the $1 million question or the $1 billion, $1 trillion question that, okay, how we are going to do the transformation. So it has to be included in all of the institutes, all of the universities, all of the companies, industries, and everywhere. It has to be a common goal because we are struggling to secure the way of living in this world, right? So that is the idea, and we think it in a different way. Okay, so we have a problem, and how we are going to reach that by making business. So you have a problem, and you are going to solve it. You are going to have a solution for that. In the same time, how we are going to make some money, how we are going to generate wealth. So that is the idea of our institute, and that's how we are doing our project. So as I told you, the oil peak is not the concern. During that carbon budget is going to end, we have a lot of problems other than that. We have a water peak. We have a lot of surface water, but the accessibility is a question. Is it really clean? Are we able to drink? So that is a big question. And the soil peak, and day by day, year by year, we are losing fertile lands. We are losing the fertility of the soil. So we have a lot of unsustainable practices around the world. So we have to overcome these things, and we have to find solutions as soon as possible. As I told you, we have a big problem. As I think you know that the Paris Agreement is about keeping the global average temperature well below 2 degrees. So if we are exceeding that level, which means we are running into big problems, and our living in this earth will be very problematic. So I will hand over the presentation to Chris now. He will talk a little bit on his topic, and then I will again jump back to my topics and give you an exposure about what is our approach in terms of doing. So Chris, you can share now your thing, and then we'll jump back. Yeah. Okay.
So I hope my screen is sharing at the moment.
We can see your presenter, Chris.
Okay, thank you.
Chris, it's presenter view. Can you
Yeah,
change it?
Sorry?
it's we can see your presenter view, not the slides.
Oh, okay.
Yeah.
So
It's on the yeah. You close it and then you go to the slide share.
okay, now I hope that's resolved.
Yeah.
Yes, all good.
Okay.
So I thought it would be a good topic to talk a little bit about land use efficiency on solar farms. As you might know, solar energy will play one of the most important roles in future energy generation. And as you can see, the solar farms take up a quite amount of land. And I thought it would be maybe interesting to talk a little bit about how much land we actually need and can we use it more efficiently. I will be just, as I don't know the background of every of the audience, I will be talking a lot about photovoltaics, which is basically electricity generation from light. And I will usually call it in short PV. All right. If we talk about land use efficiency, of course, we can always use what is already being used, like buildings. These are 3 examples from our campus, actually. So a roof can always be fitted with a solar array. There's a new trend in architecture, actually. As you know, modern architecture uses a lot of glass facades, and they tend to heat up quite a bit during the summertime, or at least in Germany in the summertime. In Sri Lanka, it's probably all around the year. And there's some need for shading, and PV can actually do that as well. These have been installed already in the 90s. Now there are more modern solutions even available. And I don't know if any one of you knows about architectural culture. Usually in Germany, there used to be something called the Bauhaus, which was like the modern architecture. And they always had this saying, form follows function, to keep buildings simple. And now there's a new saying, they say PV follows function. So the PV should be somehow integrated and should be of use for a certain purpose. Another example is solar carports, as we call them. You might know that in Sri Lanka, probably there's a lot of sun, and cars parked in the sun, they get quite hot. So it's always nice to have a little bit shading on the parking spots. And in Germany, we have about 47 million cars on the road, and they all need a place to be parked somewhere at your working place or at the supermarket. And there are actually a lot of parking lot areas that could be covered with solar. And those don't take away any space from anything else. But if we think about electricity and generation cost, this is a new study from the German Fraunhofer Institute. They analyzed how much does a unit of electricity cost for newly built generation. So as you can see, utility scale solar is by far the cheapest option. And this is from Germany. As you might know, Germany has winters. They are mostly dark, so we don't produce a lot of electricity in winter. In Sri Lanka, where you don't have these seasons, you would basically, the same module that you buy for the same price internationally would produce 50% more energy. So electricity generation costs in Sri Lanka for large utility scale solar arrays would be even lower than they are in Germany. But in Germany, they are already the cheapest option. They're cheaper than wind. But of course, in an electricity grid, it's always nice to have several types of electricity generation because they kind of complement each other. When the sun is not shining, maybe the wind will be shining. Also, as you can see, all those fossil fuels by now are the most expensive option of electricity generation. So it does not make sense nowadays to install new electricity generation with fossil fuels, because actually they're now already more expensive. In the future, they will be more so, even because carbon needs to be taxed even more if we want to go to combat climate change, and the resources won't be as readily available anymore either. So how many solar farms would we need? As I said, like the slide before, to keep electricity generation costs down and make it affordable, electricity affordable for everyone, we need to always install a certain amount of solar farms to the grid. And how much do we need? This was another study from the Fraunhofer Institute. They analyzed how much carbon emissions does Germany produce every year that are related to energy. And well, as you can see, we're the target for the new target from the German government is at 2030. We want to be at 65% of the value of 1990, and by 2050 we want to be completely carbon neutral. To do this, we have a quite steep path in front of us, and as you can see, so far we didn't do so well. So there need to be a lot more renewables installed to get us on the right track. And therefore, the Fraunhofer Institute did an analysis, and this is now including not only the electricity generation, it is including how much energy do we need for heating, how much energy do we need for industry. They included hydrogen production from renewable energy that might be needed in industry. So this is how much power we need to install. If we continue to install wind power and if we install on roofs, we would need around 150 gigawatt installed power on solar farms. I did a little bit more conservative approach. I said, okay, what happens if we can't install that much wind? What happens if we can't install that much on building? We would need around 400 gigawatt on solar farms. That's the most pessimistic approach. If we don't achieve our goals in the other sectors, we might need 400 gigawatts solar power on solar farms. And yeah, is a solar farm actually an efficient use of the land? Or do we have enough space in Germany? So with the current technology of solar, we would need for 400 gigawatt peak of installed power, we would need an area of around 4,000 square kilometers. As you might see, I don't know, it might be a little small. Germany has around 350,000 square kilometers in size. So that's a little, 4,000 is a little bit over 1% of the total land area. If you would look on the map, maybe if you take the state of the Saarland, which is down here, Berlin and Hamburg combined, you get around the area that would be needed for solar farms, which is, of course, a certain amount of area. But hang on. Currently, we are using 23,000 square kilometers for what we call bioenergy, which is mainly like half of this is corn fields that are shredded, the corn is shredded up, is fermented into gas, and they use that for energy generation. Also, we have something called rapeseed, which is a plant that produces oily seeds. They are the oil from those seeds is added to diesel to make diesel cleaner. So only for energy generation, we get like 5 times as much as we need from the solar farms. That's because those types of energy generation is highly inefficient. We get from the same area, we would get 50 times more energy from a solar farm than we get by the conversion of those plants into energy. Also, we use a lot of brown coal open pit mining in Germany. In total, we have used 2,300 square kilometers of area for those mines. Currently, there are still 600 square kilometers active mines, and the other ones are being restored at the moment, and that might take 60 years. When they close down a pit, they need 60 years for restoration. So what I actually wanted to say with this, we use a lot of area, not that efficiently. We use a lot of area for energy generation. And compared to the numbers here, actually those 4,000 doesn't seem like a lot of area. What about nature in those solar farms? What happens usually when you build a solar farm, you take an area that has been heavily used before, like in agriculture, or maybe it was a military airport before. We take a degraded area, put in a solar farm, and what we find quite often is that the biodiversity is rising. Because, well, with agriculture, you use a lot of pesticides, you use a lot of fertilizers. When you don't use them anymore, generally the biodiversity will rise. You have flowering meadows that are good for insects. They're birds, and sometimes even like they put the farm operator is obligated to put in some nature compensation measures, and sometimes they do them within the solar farm. Like here, they put in some rocks and some ponds to attract insects and reptiles. So the solar farm is an opportunity for like a nature sanctuary, actually. So it's not only energy production, but also is better for the nature. On the other hand, you can use it also multiple times, the same land. We see that quite a lot here, like sheep grazing on the solar farms. Currently in Germany, we use around 60,000 square kilometers, or 1/3 of the farmlands, to produce feed for animals. Of course, like in the solar farms, you wouldn't be producing as efficiently because you wouldn't be using fertilizers. You you have some shadings from the modules, but as you can see, the shading is actually well liked by the sheep as a cover. So you can still produce some sort of feed, animal feed, on the area of solar farms. Another big topic that's currently discussed in Germany is Agro-Photovoltaics. This is a system, a testing system in southern Germany, where they put basically solar panels on a structure above fields. And they designed them in a way that agricultural equipment still can pass below it. And their interest was, how would it be influencing the yield of the crops? As you can see, some of the field is covered with the solar panels. So actually they did measurements and they get around 70% of the light intensity on the ground as compared to sites where the solar panels are not installed. But a plant doesn't usually use all the light it can get. if some of you might know something about biology, you have a curve like this with photosynthesis. If the light intensity gets higher, in the beginning, in the dark, the plant consumes more energy than it can produce. Then with the rising light intensity, it can produce more energy, more and more energy. But at a certain point, there's a saturation point. More light won't lead to more production. And even if the light intensity gets even higher, there's something called photoinhibition. The plant needs to protect itself against the light and actually produces then less than it would with less light. Also, usually the inhibiting factor for plant growth in Germany is not the light. It's more often it's water availability and nutrient availability. And of course, when you have only 70% of the light here, that also influences evaporation, and therefore, especially in dry years, the fields below the agro-photovoltaics produce a higher yield than outside. You have special crops sometimes. This is a testing facility in the Netherlands. They produce raspberries. Raspberries is a plant that's very sensible. It is shade tolerant. It prefers shade actually, and it's sensible against hailstorms and so on. And what they do usually they put in some foils above the culture. Plastic foils that create plastic waste, of course, and they covered them with solar panels, had some water catch mechanism that is used in an automatic irrigation system. And yeah, that's another good idea how to combine crops or agriculture with solar without using any more space. Another very interesting new development in solar is vertically mounted bifacial solar arrays. These are very interesting because they are placed in an east. One side is facing east, the other side is facing west. As you might know, the sun rises in the east, hits one side of the panels, and then it passes to the other side. In the evening, it hits the other side. And the interesting thing about these panels, they can be activated from both sides. They are called bifacial. They have, instead of a plastic foil on the back side, they have another sheet of glass on the back side. Usually the bifaciality is around 80% for panels, but there are also modern panels that get above 95%. So of course, if you use both sides of the panel, the higher the amount you get on the back side as well, the better for efficiency. I did some calculations for Sri Lanka yesterday, and I saw that actually that works just as well in Sri Lanka as it works in Germany. As you get around 50% or 60% of the usual yield you would get for a perfectly mounted panel on the one side, and you get around 40 to 45% on the other side. So actually, you can produce more energy from a vertically mounted solar array than a perfectly mounted solar array. There are some disadvantages. Of course, the panels are a little bit more expensive, and you need to you have higher wind loads, so the mounting system needs to be a little bit stronger. So this amounts to 10 to 15% higher costs. But of course, you influence very little the area. Well, the area, you need to leave a lot of space in between, because to avoid that one row will shade the next row. So you have a lot of space in between that you still can use for agriculture. And another advantage is that they produce to a different time as normally mounted panels would. So in combination, if you combine normally mounted panels with the vertically mounted panels, you get a very even distribution of energy generation throughout the day. And therefore you need less storage. They can also be used as a fence, which is another interesting idea. You might need to build a fence anyways. Why not build it with solar? here, that's something that would only be working in Germany. As you can see, they are in 90-degree angle to each other. So these are facing south and north. On the north side, you still get around 20% of energy generation because you always have some diffuse light that's reflecting from other surfaces, so you get 20%. But these panels produce especially good in winter because in Germany the sun is very low, so the south-facing panels will produce a lot in winter, which would not be the case in Sri Lanka as the sun is always kind of high. So in Sri Lanka, only the east-west facing would work well. And let me come to the conclusion. Germany is very densely populated and industrialized nation. In winter, the solar yield is low. So Germany is not the ideal place to get 100% renewable energy generation. But it is possible for us, very well possible. And if it's possible for us, it should be for Sri Lanka too. Solar energy is already the cheapest form of energy generation in Germany. And I would assume in Sri Lanka it is as well. We only need 1% of the land area to become 100% renewable. In Sri Lanka, of course, you have a little higher population density than Germany, but we use more energy per capita. So I would assume it should be less than 1% of the land area needed for solar generation. There's more energy, more area currently used in other forms that are inefficient, like the bioenergy, or unsustainable, like the brown coal energy. Of course, you can't use all those areas that might not be ideal for solar generation. But if we don't use them for energy generation anymore because we have the solar, we can use them for something else. Solar energy generation does not be a single use case. You can also use the area in a second way. And there are many innovative solutions available to improve land use efficiency. Thank you very much for your attention.
Okay, Chris, thank you. I think the audience must have questions, but I think you are waiting until the end, so we'll wait until the end.
If they have questions, it would be better to ask now because
if so,
I can stay until the end.
Yeah. So if you have any questions, you can ask from Chris. So, and I asked him to do this in advance because I wanted to show how the applicability is going to that applicability of the renewable energy is going to work with the circular economy and material flow management aspect. So now, since he has shown some real photos, I think it's clear for you that these are not sort of like fancy things or fantasies. These are really happening in somewhere around the world. So it's a matter of question why we can't do that. So it seems there's no questions. So I will start since we have limited time. Okay.
Navoda.
Yeah.
Navoda, I would like to talk to our audience. We have mineral resource students as well as we have academics who have joined today.
Yeah.
And I would like to request them, if they have any questions, they can unmute themselves and they can talk also.
Okay.
I encourage them, our students especially, if they have any questions, they can put it into the chat box.
Okay, yeah.
Right. You can proceed now.
Okay. You can see the screen?
Yeah, all good.
Yeah, okay. So as I told you before, I will not go into much detail on definitions and theories and calculations. I just wanted to give you an exposure of what we do. As you have all seen from Chris' presentation, that the renewable energy is one of the biggest part in the coming world. So if you see that we are using in Germany, they are using like some panels to at least to harness around 20%. But in Sri Lanka, we have much more capacity. So it's all about managing money and managing the plan into a working level. So why in Germany those things are practiced? Because they are focusing for the circular economy, and most of the places in the country, they are practicing this. So that is, I believe personally, that is one of the reasons that the Germany could able to, or the Germany got the chance to bounce back in well with the pandemic situation as well. So what is circular economy? Circular economy is limiting the dependency to the outer world and maximizing the resources within your own system boundary. So it is starting from the product design and until the end use. We are focusing on design out the waste. So it is about generating wealth, creating jobs inside the community, and also minimizing the waste. So for example, in the linear economy, what we are practicing in Sri Lanka at the moment, what we do is we extract certain amount of material, we use and we dispose it, that's it. But when it comes to the real situation, we are dealing with finite resources that will be finished after a certain time. So the sustainability, the idea is that we have to keep these resources for future generations as well. So the circular economy is not just an economic model, it's a reshaping of the world. And this can be applied into any system. It can be a house or a company or a small or big company, institute, whatsoever. And that's what we do. So the prime goal is to achieve the circular economy model, and these are some sketches. So for example, in linear economy, the more the energy supplier or the energy supplied by fossil fuels. In circular economy, we are much focusing on the resources which are available inside the system. For example, Germany is spending nearly 100 billion euros to import crude oil, because Germany is only having Germany has only coal. So they have to spend nearly 100 billion euros every year. So what they are targeting is they are trying to maximize their renewable energy share in the energy mix, so they can keep that wealth inside the country, so they can send it to healthcare, education, or whatsoever. So these are some diagrams that I used to show you, and I'm going a little bit fast, but if you have any questions, please ask in the middle, as Mr. Jagat told. So these things you can find online. There are a lot of definitions, a lot of diagrams which explains everything, and there are a lot of explanatory videos in YouTube. So I will not talk in detail, just to give you an exposure. So as I told you, if we need to close the loop and take the resources back into the cycle, we need to have a mechanism. So this is a simple example that I took to show you. So in every supermarket, these machines are fixed. These are reverse vending machines. For example, this is a normal Coca-Cola bottle that you can buy from a supermarket or a coffee shop in here. So if you can see, there is a mark here. This has a value, or this can be refunded, and this has a value of 25 cents. So the meaning is that these things will not rely on gardens or drains or parks in the roads or wherever. This will not rely on those places, because when I have this one, I will keep it, and when I go to the supermarket, I will put it into the machine and I get the refund back. So even at my home here, we are collecting beer cans, plastic bottles, and per every week, nearly worth around 4 or 5 euros every week. So that amount is deducted from the bill, and we are getting rid of the waste as well, because a waste is the wrong material at the wrong place at the wrong time. So once I use this bottle, after that, after finishing the liquid, whatever inside here, I don't have a requirement of this bottle. So at that stage, I'm looking how to get rid of that. But when it comes to reality, this is a resource, and someone or the manufacturer of this bottle can have a benefit out of that. So we have to have an infrastructure which works we can close the loop. So whenever we buy an aluminum can or a bottle from the supermarket, there is a refund included in it. So we are paying at the beginning and then we are refunding at the end. So it's a nice work, and these things can be practiced everywhere. So it's about the mindset and understanding the importance of closing the loop. And so circular economy is the approach or the prime goal, but how we are going to reach that. So material flow analysis and the material flow management is a set of tools which enables to reach a circular economy. Its material flow analysis is all about understanding the system, starting from material input, material costs, energy cost, energy flows, and at the end we know what we have in our system in terms of waste, in terms of material input, energy, and everything. So to understand the situation and to come up with solutions, we need to know the material flows inside our system. So that is the idea of material flow analysis, and it is not a simple set of tasks. There are certain approaches. We have to define system boundary, and then we have to collect data. So actually the calculation and the business aspect of that at the end is not that much hard, but collecting data, identify the reliability of data, closing the gaps in data is the hardest part. So we have to have a lot of approach towards that in terms of this kind of a project, much towards the data quality and gathering data. And then we have to see what we can do from these material streams. So this is also an idea. In here you can see the zero emission strategy or the resilience strategy. When you identify your potential within your system, you know what you can reach. For example, if you have renewable energy potential, once you applied it into a system, that means you are saving a certain amount of money which is going out from your system, and you are directing that back into your system to have a better living, and you will spend it more on your education. You will spend it more of your quality of living. So that is the idea. And as you saw from Chris' presentation, that is the reason that we are using a lot of quality products, like a lot of materials into solar PV, because of course it costs a lot, but the question you should ask, where this money come from? Because that money comes from the money going out, because we are saving from that and we are injecting it to a new system. It will create jobs, it will create a certain set of value chains, and of course it will save a lot of money that we can put into ourselves in the future. So this is a simple graph which shows the importance of material flow management. And if we have a throughput society, that means we extract materials, we consume, and then we throw it away. If that is the way we want to practice, the global material and energy demand will start to rise, and it will not stop, and then we have much bigger problems. But when you apply material flow management here, then we can reach to a sustainable level where we have secure access to the energy and also resources. And so circular economy, material flow management, and these concepts are used in one of the projects that we are doing here, resources and energy efficiency checks. That's where I'm working most of the time for the projects. Yes, of course, the material flow management is the base of this. We go to systems and we understand the system, and then we do the improvements. So this is a project funded by a bank called KfW, DEG, Deutsche Entwicklungsgesellschaft. It means German Investment Corporation. So they are funding, or they are paying us to go to certain customers of the bank who are in their credit list. So we are visiting those factories, and we are giving energy and resource efficiency projects for them to understand and to implement. So I last 6 to 7 years, we have did nearly 12, 13, or I think around 15 visits, and these are some of them. And I've been to Kenya in 2019, and I work with the Costa Rican projects and the Chinese projects as well. So these are different industries. So, and I had the question when I had to go to Kenya, it was a food and beverage industry, and I was asking the question myself. I did mineral processing technology, and what I'm doing here is that what I really want to do? And I had that question. So, but at that time I was a student and I was entitled to that project. So I went, everything was paid and no problem. When I was there, I understood there are really, really minor changes compared to a ceramic processing factory. And I used to work in there when I was in Sri Lanka. So for example, in this food processing facility, they have smaller ball mills. In the ceramic factory, we have much bigger ones with rugged versions with higher power consumption. So I had, and also this food processing factory had a 24/7 running small oven for heat up their food products. And in the same way, in the ceramic factories, tile factories, they have 24/7 running kilns. So what's the difference? The difference is they are different changes. Okay, the same systems are in everywhere, compressed air, motors, ball mills, kilns, furnaces, and everything. They are in different scales and different settings in each sector. So then I understood, okay, my path is correct. And of course, I had the knowledge to do energy balances and carbon balances and everything from my master's. But I always wanted to combine these things, like, what I did for my bachelor's and what I did for my master's. So if I'm going to change the industry, I don't like it and I don't want to do that. So what we are doing in the REC, or the resources and energy efficiency check, as I told you, I think the next slide would be much interesting. Yeah. So we evaluate the status quo, and then we come up with certain set of projects where we can implement energy efficiency, and if there are any other potential for renewable energy. And then we analyze the suitable improvement technology based on the best available technologies. For example, we are working with some of the German technology providers. For example, we are working with the big pump manufacturer called KSB. So when we are on site, and if we have a pump replacement project, we are taking their actual data, the cost, their specification of the systems, and then we do the calculations and we check the saving potential. So, and it is no way of recommending these suppliers to them. It's just to show that we know, because you already know Germany has high standard of in terms of technology and the advancement and the quality, of course, and the lifespan. So we are showing our clients that, okay, this is the reference or the benchmark that you can go when you spend this amount of money. So this is the saving that you are getting. So as I told you before, what we are doing is we are always coupling business with the climate change. So whenever we do, or whenever we introduce this kind of a project, we need to show the business potential or the financial strength of the project, like IRR and those financial figures, and also the environmental benefits. So then the companies are all up on ears. And it is really happy to say that most of the companies that we did these projects, they implemented, not all, but to a certain extent. And yeah, so this one here you can see this is the approach from our side. So this is the 100% is the status quo, or the consumption level at the status quo when we do the initial analysis. And by experience, we know in almost all the companies, we can reduce 15% of energy consumption by only raising awareness, by telling them not to do this or don't do that. and by load management practices. So we know by our practice, it's around 15% is already saved by raising awareness. And then it comes to the plug and play things like changing lights from LEDs, because these are just plug and play things, and changing the shower heads, for example, in big hotels or industries, changing the tower heads, the shower heads of big washing plants. So by that, it is possible to save around in between the 20 and 30%. So these numbers are based on our experience. So this is our approach. And then it comes to the a little bit advanced part, where we have to introduce new technology or new systems, and we will recommend certain technology, for example, replace the pump system like that. Then it needs much higher advanced set of calculations to show the actual savings, and also the financial outcome of the project. And then after reducing to that level, this is the strategic planning, where we can integrate renewable energy. So by this, you can understand why most of the Sri Lankan companies say, oh, this, for example, PV is not profitable. We cannot get at least the payback is not so close. So why is that? You can see it has to be planned from the beginning. So for example, if you want to introduce renewable at this stage, at this 100% stage or the status quo stage, it doesn't make any sense, because in here you can see it's nearly 30-50% is a waste. So you are developing a much capital intensive system to supply to waste as well. So that is the problem, and that is why we have this approach. And almost all the projects that we supported in terms of that, for example, I did my thesis with the Sri Lankan company for the master's thesis, a ceramic factory in Anuradhapura, and I'm really happy to say they have practiced it in this way, and now they are going to rent their rooftop to a solar PV system. So this is actually the model that I presented for them in 2019. So as I told you, since we are dealing with the business, they always want to see what is the effect on their cash flow. So it has to have nice figures. So this is a project that we did in 2020 with the collaboration of Rajaratnam University of Sri Lanka. We did the renewable resources and energy efficiency check to few of the regional companies, and this is for one of the apparel sector companies. And they have a big boiler, and they are using the condensate return has a big problem. So we proposed solar thermal, and we did intensive calculations. So you can see the payback period it's really interesting, and nearly $1,000 or $2,000 for that company is nothing. So it's all about proper planning and directing the money into the correct direction. And this is also a set of real calculation what I did for a ceramic factory, and how they can how they can include the biomass energy to their energy mix, because they have a 24/7 running kiln, and the temperature is not that much high. It's around 800-900 Celsius. And these are the final presented values. And as you can see, the average electricity unit price, what they are purchasing at the moment, at that time, it was 2019 end, and it's around $0.075. It's around 11 or 12 rupees at that time. So from this system, from the cogeneration unit, you can produce the heat what they need in that level. So the LCOE is known as the levelized cost of energy. So it is very important to understand in energy projects. So, and it should be always lower than the energy that we are purchasing at the moment. And also this is the heat energy. And when we calculate their heat energy, how much they are paying at the moment, they were using diesel, pyrolysis oil, and some partial portion from LPG as well. So at the moment, they are paying around, this is the weighted average heat price. It's around 0.062. And you can see the levelized cost of energy of the proposed plan. And this include all the discount rates, operating expenditures, maintenance, and everything. So the idea is that securing your resources in your system and be much as possible independent from the outer world. And this is from our experience. Sorry, I have used the German version, but that's fine. So this says that based on our experience, this is the amount that we can save from a fairly managed company. Bellushtung is the lighting, and then this is compressed air, this is pump, and then the cooling and cool water, and this is hot water and heat, and this is the air for ventilation. So these are based on our average values, based on our experience. And some of the companies we can save, we did also in one of the dairy production facility in Costa Rica, the savings from pumps alone around 55%. So these are some average values. Finally, I want to show you that how these things are taken into action. And the best example is where am I sitting right now. And here, as I told you, this is our university. And in the nearby location, we have a heating power plant or combined heat and power station. What they do is they collect the waste from the region, and they have a cogeneration plant, and they supply the heat and hot water, the space heating and the hot water for the campus. And also they have a biogas plant, and the digestate is sent to the cogeneration plant as the gas. And then the liquid fertilizer and the fertilizer part is sold to regional communities. So this is really happening. This is actually happening at the moment. And this region, this company also supplying electricity for domestic purpose as well. So these are real happening things, and it's just a proper management and directing the proper financial sources. And this is the most important curve that I wanted to show you today. And this is the last slide from the topic that I wanted to talk. So this is called as a Kuznets curve. And in here, this y-axis or the vertical axis is the level of environmental degradation. That means when the country is poor, they don't care about the environment, and they waste, and they don't care about the water or health or whatsoever. They are just polluting and polluting. They just have financial problems. That's so for whole financial problems. And when it comes to a level, and when they are a little bit rich, then they understand, okay, we need quality. We need to change the way of living. We need to have better standards. Then what they will do is they will spend a lot of money to come to this level again, right? So I think you can understand. So the meaning is they earn a lot and they create wealth. For example, China is somewhere here right now. Okay, so they are still reaching this level. So this is a moment of understanding. Okay, one of my professors in this campus told me when they were kids, like 40, 50 years ago, they are not allowed to step into rivers because it's so polluted. But now they are crystal clear because they have spent a lot of money to clean and to apply strategies to save the environment. For example, there are professors and a lot of employees in here. They are coming to the campus by foot cycles on summer because they know the impact. So they have the infrastructure and they are using. So the idea here is a bell-shaped curve. So if let's say we are here right now, and you can see we don't need to go all the way from here. We can just shift from here to here. We need some policy-wise and technical-wise, and of course, in terms of knowledge, changes. Then we don't have to go along all the way from here and here. So because we are in a stress, we are in a big environmental stress, so we have to act fast. So that is the main part in terms of my job, what I'm doing in our institute. These are the concepts that we are promoting in terms of knowledge and projects. And currently I'm working in 2 projects. One is in UK and one in Namibia. So these are 2 of the biggest projects in our institute at the moment. Both are actually the UK project is based on some of the energy management and energy efficiency improvement. The Namibia is much more into biomass handling and total land use management aspect. So as I told you before, I'm a mineral resources and technology student in the beginning. So I always wanted to combine my bachelor's and master's all together. So then I came up with this topic and I presented it to one of the supervisors in University of Freiburg. It is the world oldest mining academy, and he was interested and he took me in. And now I'm doing parallelly to my job and the other work. This is my own topic. I don't have any stress, so I'm doing it. I'm creating a model for industrial mineral processing and mining facilities to model their energy consumption, resource efficiency, and how they can be much efficient in the coming future. Because I personally believe that when I learned mineral processing technology in 2011 to 2015, the feeling that I got is that we are not supposed to help only to one company or like that. We are here to cater the whole industrial sector. So I want to value add to the whole mineral sector or the mining sector in Sri Lanka or wherever. And this is the link that I have here. So I don't have a direct relation with my job with the PhD, but also since the energy and every aspect of the material flow management will be used in my PhD topic as well. So why I selected UW, as I told you, I'm already working with some of the professors and doctors in the country, and I had to postpone some of the task because of the pandemic. I could not travel to Sri Lanka last year and this year. So the reason is that UW or mineral processing technology students in UW have an interdisciplinary approach. So that is most important when we talk about this holistic approach towards the climate change. So that is why the UW is the best place for me to collaborate with. And I'm full open, and I have several topics that I have already shared, and 2 are already taken. And I have new topics coming in. So if anyone is interested, I'm happy to help. And why this one is so special, that is the question we should ask, because a circular economy, material flow management, or these sustainable concepts are not aligned with the mining or mineral processing. Because when we talk about mineral processing or when we talk about mining, it's always destroying the earth or the ground, or we have to remove the topsoil, and it's a big damage. But we all know we need mining. We need mining to a certain extent. We need some of the materials. There are some materials which cannot be replaced by alternatives. So the mining should be there. But the question we should ask is, okay, how we are going to integrate and how we are going to see the way, how we can do it in a different way or change the way of looking at things. So that is the idea of this one. And the benefit of this model is that I'm using this in our sector as a reference model, because I used to work in the mineral processing industry. I have some contacts. I have a certain level of knowledge on that aspect. So I can use it as the reference industry. When it is done, this model can be applied into any industry. So that is the selling point of this project. So that's why my supervisors were really interested on that, and this became a combined program. And I don't have any funds at the moment, but I have access to some of the funds. And after I arrange certain collaboration with companies, universities, and students with Sri Lanka, I will bring that too. At the moment, I don't have any need. So this is my main university. This is where I'm getting the PhD, and because I'm at the moment, the Umwelt campus Bergenfeld is an applied science university, and in Germany, universities of applied sciences are not capable of providing PhDs. So we can, based on these universities, as PhD or doctoral candidates, but providing PhDs are done by technical universities. I have heard that there are some applied science universities who are capable of providing PhDs, but I'm not sure on that. So this is the link that I had and I'm having right now. So I always wanted to work with Sri Lanka. And the fundamental question that I'm asking is that I have the potential to consult clients and to work with companies from Kenya, UK, Costa Rica, Mexico, USA, and they are capable of doing these things. But it is very hard for me to come to Sri Lanka and convince these people. And as far as I understood, I think it's the awareness is not that much there. So this is of course a hard route, but we have to try. So I'm in the course of changing the way of people have to think. And that's all from my end today. And it's most important thing for you to think for the students here that the commitment is the key, and you have to have a professional goal. Okay, sometimes that professional goal only requires a bachelor's. You don't need to have a master's. That might be possible. So that is the hard part. You have to identify the professional goal or the professional position that you want to be in, and then the solution is much easier, right? So, for example, if you are in Badul and if you want to go to Colombo, you know your destination, and the only thing you have to figure out how you are going to go. You can walk, or you can have a bus ride, or you can rent a car, or you can drive your own vehicle. If you want to rent a car with a driver, or are you going to drive? If you are going to drive, I need to have a driver's license. Do I have it? So then when you define the final end, you know what you want to collect in that route. Okay, so that is it's really simple. When you have defined your final goal, everything will become easier. So for me now, I'm I achieved my professional target. Now it's a matter of fact that I'm developing it in the coming future. So, and I'm also combining my master's and bachelor's together. So I need a validation for that. That's why I selected my own topic for the PhD. Yeah, so I think I have given some interesting information, and I'm happy to talk to you back again if it is possible. And for sure, when I'm in Sri Lanka next time, I want to visit Sri Lanka, Uvavelas University, and I have a lot of things to discuss, and I have a lot of plans to initiate, and I am in a position that I can help. So yeah, thank you very much. And if you have any question, you can go ahead. And I'm not sure if we have enough time. That is something to decide from Dagatse. So yeah, so these are my contact details. This is my office email, and this is my personal mobile number. So I'm in WhatsApp or whatsoever, so you can contact me. If you need any help, or if you are interested in collaborating with me for the topics, we can talk. Yeah, and that's from my end. And I got a message from Chris that he has to go because as I told you before, I think I talked to Jagatsa that we are a little busy at these days because most of us are going for vacation with the summer break. So we are getting some instant meetings and calls, and we have to take care of others' work if it is an emergency. So we were a little bit busy on work, so that's why he had to go. So if you have any information, I also can share his details with you if you need any information from him. Yeah, thank you very much.
Okay, thank you, Navoda. Glad to hear from you, and it's a great pleasure to see that you have reached your goal. I think, but there is more to go, and we from our end, from as ULS University, we would like to congratulate on your success as well as we wish you all the best in your future. But
yeah, thank you very much.
this is not the end. Now we have, it's time to move to our audience. We have our students who study mineral resource technology, as well as we have academics who have joined today. I would like to thank them also spending their time with the webinar. And now I will open the webinar to everyone. It's your time to ask any questions. Navoda is there. Also our academics are there. If I name, I think Professor Jagat Pitawala is there, Dr. Titus Kure is there, and also Dr. Yes, Amila Sandharwan also there. So I would like to see that to have a small discussion on the things we discuss on mineral resources, especially Navoda highlighted on integrated circular economy. So it's quite, I think, new topic to discuss. Also, he discussed mainly about the sustainability, also about the zero emission. Now the forum is open for you for the discussion. So if you have any questions or ideas, then you can unmute yourself. Also, we would like to hear from you, our students. So if you find any questions, then you can raise questions.
First of all, I like to congratulate you for being a PhD candidate in Germany in this place. Yeah. And you gave us a very nice and descriptive talk about your study. My question is, maybe this is little connect between Chris' talk and your talk. Yeah. You mentioned that when considering the generation cost, PV is have the lowest, but considering the capital cost, still it is very difficult to convince developing countries to invest for solar power. Yeah. So what is the hurdle here? Because we have a lot of, considering developing countries, our land price is not that much. We can construct solar parks in anywhere. Yeah. So what is the big hurdle that we have to overcome?
For example, when in our cases, when we develop these kind of projects, of course there is a big problem starting from the production of the power, the panels. For example, it has a big material intensity for like silicon dioxide and these kind of things. But when it comes to the purchasing power of a country like Sri Lanka, you are correct, because most of the companies, when we also propose this kind of project, or they said, okay, the capital is a little bit high, how we are going to afford that? So that is come into the planning, and that sometimes always we are always promoting, because there are some companies in Europe who can build the system for them, right? So they are building the system for them, and they are like building, operating, and what the other word I can't remember. So what they do is they are in a partnership. You know, the carbon trading platforms, we have carbon trading platforms in Germany. So what they do is they are investing on countries like us, and they build the solar PV plant or a farm, and then they sell that electricity to our country. So then, for example, it can be done by a small company as well. So in Germany, for example, there are some banks who have collected the funds together, and they are distributing it among the domestic people, the normal people. So when they plan, like, okay, our approach is to reach 10 megawatt peaks by 2025. So then they know we need this much amount of money and how we are going to distribute it and how much is the investment we need. So when it comes to the capital investment, how we do is that we always we go towards that approach by analyzing the system and reducing the inefficiencies in the first, and then we integrate or introduce renewable energy. So first we need to get rid of the inefficiencies. So that's why I told you some of the companies that we are working with in Sri Lanka, for example, private companies who are suppliers of PV units, they always saying that the problem with the customers is they are not doing the basics that they have to do in the beginning. So in order to maximize the levelized cost of energy, that what we can get back after the project. So it's actually a financial planning. So now, for example, in Germany, when we do the calculations, if we don't have real values from a supplier, what we do is we assume a value for unit price, like 1,000 euros per kilowatt peak of the PV system. It includes all the labor, maintenance, and everything for the initial cost. But nowadays, like 2-3 years ago, it was like 1,000 euros, but nowadays it's around 700 euros. So it means the technology is developing and the price is going down for these technologies. And there are a lot of brands coming from China now. So the market is a little bit wide. So we have a lot of options. So the hurdle as if you want to, I mean, if I have to give you a direct answer, I would say the hurdle in Sri Lanka, I don't see a hurdle. It's actually a problem in planning. You can see that Sri Lanka is how much spending money for unnecessary things. For example, I have seen some people who are buying vehicles with very high amount of prices. So this is to establish a PV plant in their house is not that much cost, and after 7 or 8 years, it's a money printing machine. So it's a process of planning, and first we need to understand the benefit. And from my aspect, I think it's not a problem in terms of money. Of course, it's costly. Of course, all the renewable energy technologies are costly. They have a big cost. So from my aspect, I think it's a proper planning of planning and sharing the risk. Yeah, I think I gave you actually it's very hard to give that kind of an answer, because it always the way of the customer thinks, and most of the companies in Sri Lanka, they don't want to do PV. And as Chris told you, in Germany, we have like 4 to 5 months. It's nearly gloomy and we don't have sunlight to generate electricity. But still, our university, we are producing 100% electricity, which are enough for the whole year. And then we are running with the net zero balance, but still we are creating that amount. So it's a process of planning. And as I told you, since we have carbon trading schemes in Europe and some other countries, the companies in Germany, they can invest on Sri Lanka and they can get the carbon credits for them. So these are always promoted by ourselves for these practices, and I think there are some companies already doing that. Yeah, that is one way to overcome the capital expenditure problem, and after 15 or 10 years, they hand over the system to ours as well, based on the financials of the project. Yeah.
Okay, thank you. Thank you very much for well explained answer. I have another question regarding this is not related to PV only. Now the lifetime of one plant would be about 30 years, right? Am I right?
Yeah. Now there are systems for like even for 40 years.
So now you are using a lot of material and batteries.
Yeah.
And maybe in your country now there are, in Germany, you are from here.
Yeah, still I'm Sri Lankan.
In Germany, there may be a lot of electric vehicles as well.
Yeah.
So maybe you remember you had a big issue when you are a student here, what we are going to do for cell phone rechargeable batteries.
Yeah.
So how Germany is handling this issue, the batteries coming from solar parks as well as the electric vehicles?
Yeah.
How you are recycling them?
we have a lot of recycling plants, the hazardous electrical and electronic waste recycling plants. I think I have a presentation. I will search it and will send it to you. So they are in the phase of changing the design thing, that from the design perspective, that how the recycling is going to be easy. And we are working with a company called Tomra. They are also they're actually a sorting facility, and they are giving us the feedback how we can develop the products in the final phase for them to sort out. And in terms of recycling, there are a lot of research and what we call that the funds are available. So those things, and as you told, it's when it comes to renewable energy and battery, these things, it's really material intensified industries. So that's why we need to expand the lifespan and of the system, 20, 30 or more than even that. And after 30 years, then we have the problem. Okay, we have worn out or wasted materials, and now what we are going to do. So they are in the phase at the moment right now doing the research trend. So it is, for example, now there are some companies who can do the recycling for all solar panels and extract materials. And for batteries, there are few, but it is not that much into the best level. For example, now aluminum cans and these things are perfectly recycled in here. But the batteries and these high-end electronical and electrical hazardous waste is not that much recycled, even in anywhere in the Europe. But Germany, I think, and I know by personally, because I have worked with some of the companies, they are in the research trend, and there are a lot of research positions are open for that, and there is a huge amount of money. So it's a question that we have to face in like after 20, 30 years in the future. So they are preparing right now at the moment, and even now they are thinking of getting rid of the batteries and how to integrate hydrogen. So in our university also we are planning a hydrogen power plant in the coming years, the green hydrogen power plant. So these are some discussions. So the recycling part is happening here for most of the electronic and hazardous waste, but for the batteries, it's still on research trend, and there are low portion of batteries are recycled. And for example, in our university also, we have separate bins within the campus to specifically for batteries, rechargeable or non-rechargeable whatsoever. So it is happening here, and I think it will be a matter of time in the future.
Okay, Navoda, thank you very much.
Yeah, thank you, sir.
Thank you, Dr. Titus, for sharing ideas and also starting the discussion. Dr. Amila is there, I think.
Yes, Jagan. So, Navoda, thank you very much for your nice presentation and nice discussion. And I would like to see your progress since I know you from your school time.
And, 2007, I think.
Yeah, yes, around 2007. And so I have two questions. Okay. So first question is very general one. So what is the key message that you can give for our MRT or UW students? So that is my first question. And
what is sorry,
key message.
Okay, yeah.
That you can give for our MRT or UW students. And second question is, and when we considering about value addition of mineral resources in Sri Lanka, so one of the major question is energy price. So energy price is very high in Sri Lanka. So therefore it's very difficult to bring some investors to Sri Lanka. So they criticize about this one. So every time they mention, so energy price is very high and it's not stable in Sri Lanka. So therefore the value addition is one of the major challenges in value addition. So what is your recommendation or what is your suggestion for that one? So do you have any idea for some kind of alternative things for that?
Yeah, so that is actually the one of the prime goal of my PhD topic, to address this issue and come up with at least to identify, because I will give you an example. If you ask me, if you ask from me, what is the let's take Kahataga graphite mine, for example. And if you ask from me, what is the, of course, we know there is a valuable material underground and the shaft is there, the tunnels are already made. But now if you ask what is the most important system for that mine, I would say the ventilation system, right? Because you need people to stay underground and it has to be function all the time. And I was there, I think in 2013 or 14, as from a site visit from the campus. And when you are underground, you can clearly hear the leaks of the ventilation system, right? So if you consider only that part, we know by this here, because Germans, they will be going crazy if they hear this kind of a sound in their system, because they know how much is a waste, because compressed air is one of the biggest waste or inefficient system in any of the factory. So by having a pin size hole in the network, if it is around 7 kilowatt compressor, the annual energy loss or the annual energy loss in terms of cost is around $7,000. So you can see what I'm talking. So it's just an example. So first, from my part, as I'm in this energy and climate sector, I think first we need to address these inefficiencies and to take a look well into the systems. Are we doing the thing correctly? So that's why, because when it comes to a factory where we have to rely on big energy costs, or energy, for example, a ceramic factory, they have to have electricity from the national grid and LPG from outside sources to run their kilns. So that means those are two prices that we cannot control inside from the university or the company. It is because they are purchasing from outside. So that's why my approach, or the approach from our institute, is we are always proposing energy mix. So we have to supply a portion of energy from renewables, and of course we do need to do the fuel switching. Because in Sri Lanka, when we come to Sri Lanka and if we propose high-end renewable technologies to these institutes or any of the companies, they don't listen. It's not practical as well, because it will be a lot of cost. So in that stage, what we can do is we can see different fuel switches even in the fossil fuel sector. So if it is, are we going to use diesel or are we going to LPG? So then it comes to the calculation where we can identify the levelized cost of energy. So then it is a close or an in detail analysis of the different energy carriers and what we have in terms of renewable energy sources. So it is, to be honest, I don't have a clear answer on that, but since we are depending so much on outside fuel from other countries, that is the big problem. We all know if there is a delay on one coal shipment, there is no electricity for 2 days. So how sad. So now I'm in here, Germany, for nearly 4 years. In my life, I haven't had a single power cut. Never. So that is the energy security we have here. So it's not about only renewables. It's also how we are going to have energy security inside the company, and it has to come from the beginning, as I show you in the graph. First, we need to identify the inefficiencies, and then we have to raise the awareness, and then we have to do the plug and play things, the small ROI things, and then, of course, the renewable energy integration. So normally in Sri Lanka, if you have access to the money or proper financial tools, nearly 50% of the energy can be supplied from renewables. And also it is really interesting that the grid feed-in tariff in Sri Lanka is really attractive. I think it's around 22 rupees at the moment. So it's all about proper planning. Yeah, so I think I can give you an answer to that, a clear-cut answer to that after like 2 or 3 years at the end of my PhD, because that's also one of my prime goals in the topic. Yeah.
Thank you. Navoda.
Yeah.
Jagat, can I speak?
Yes, Professor
Of
Vitavel.
course.
Yeah.
Hello, sir.
Hello. First of all, very nice session. Thank you very much, Jagat and team for the organizing, and also we have to thank Chris for his very nice presentation. Of course, Navoda, because as Dr. Titus and Dr. Amila mentioned, we are very happy about you because you are a UW product. So we can use you as a role model. My message is to our undergraduate student. You see UW products now where they are. So it's a very good thing. After I joined ULS University, I closely, one of my closest students is Navoda. So then I am really happy about your progress. When we think about the topic that we discuss, I am really familiar with that because my research areas are also energy conversion and energy storage devices, lithium batteries and solar cells, and also now my new interest on waste management. So one example I can give you, you mentioned about lithium battery recycling. Actually, 2 years ago, I did a research on how to extract the materials from waste batteries. So
Yeah.
I know what are the materials we have there. So graphite and lithium cobalt oxide, those things we were managed to extract.
Yeah.
Then the main problem in Sri Lanka, I think you didn't mention, but I have to mention there are some political barriers also. I don't know why
Of course.
everything we have.
Yeah.
I have also experienced 6 years experience in Europe. That you saw everything. I have also seen the problem why we can't incorporate these things in our country. I always
Yeah, of course.
that's the main thing. What are the Dr. Titus also mentioned? What are the barriers? Just think about the machine that we have in this recycling plastic bottle and metal cans.
Yeah.
So we can easily establish in Kargil's or Food City,
Yeah.
very near to Food City or Kargil's, right?
Yeah, exactly.
So, very simple thing. Therefore, at least it's very good motivation you gave for our students because they are the younger generation of our country. Now, my request, you can think, you can think about the possibilities, and from our side as a senior scientist, we will help for our young generation. So thank you very much. It is very nice, and I think this is from my side. I thought that we should invite you as a keynote speaker for a conference because those things. No, that's nice because very good message you gave. Anyway, we can talk more, and we need a good your future help for the development of the ULS University. Definitely.
Yeah, sir, of course.
Yeah.
I was planning to come, but with the pandemic, there are a lot of uncertainties in the opening and closing the airport. So I can't get the risk being stuck in Sri Lanka. So that's why I had to skip those plans to the next year.
Yeah. Because you have UW blood, so definitely first you will give the help to develop the university.
Yeah, for sure.
Yeah, so that is a general discussion that I wanted to say. Actually, our undergraduate student again think you can go as you can be another Navoda. So one question that I have, because students also may have some questions, we have to give the time to them. So when we think about, because I told you I have experience in Europe, and they have very industry university collaboration, right? PhDs are coming from the industry. So how do we can develop this culture in Sri Lanka? Industry university linkages. What are the things that we have to start? From your experience, can you tell us?
Okay, that is the, I think it's a good question, and that is one of the reason I wanted to come to Uvellas University as well. And last year, I think Dr. Amila already know that I tried to bring the VC to Germany, but unfortunately due to the pandemic situation, it did not get work. So the best example is what we are doing here in this institute. So my approach is also the same, that we can start a small, like a small consultancy firm based on our campus. So what we do is we do research for the companies, and we also, of course, there are a lot of funds, and I think Dr. Peter will already know that there are a lot of funds available in the European Union for these kind of projects. And for example, Ifas also funded by these kind of funding tools. So, and that also one of my projects I started in 2016 is still ongoing, and to increase the research trend and the industry collaboration together. Because from my experience, I know when I used to work in the ceramic factory, there are hundreds of research topics that we can deliver for students. And there are hundreds of students, in the other hand, who are looking for research topics. So it's just a platform where we need to connect them, because sometimes, in Sri Lanka also, the students, when they are in internship, they are not getting paid, and they have to complete an internship also. And sometimes it's 500 rupees or something per day when we did the internship. So for the company, that is nothing. So it's only a matter of connecting them, and we need to have a base from our aspect. For example, in this university, there are 8 or 9 institutes, including our one. So what we do is we are working with industries, and we are convincing them, okay, we have these things. For example, I'm sorry to say like this, but when we were in university time, what we did as industrial visits, we go to the industries and we take a look on the company, and when we came to the university, we give a report about what we have seen. But in here, it's other way around. But students are promoting things. Students are giving suggestions to the company. So that's why they are interested. I think that is the first step we should take. We have to turn the table around. So we are not going to the company and see these things, because these days the information is available everywhere. So only thing you have to think, okay, where I'm going to look, what to look. That's all. So I learned a lot of things, because I'm not a mechanical engineer, and in my projects in here, there are a lot of mechanical engineering parts are applied. So I had to learn a lot. So there are nice YouTube channels. There are nice published peer-reviewed materials in Elsevier or Springer for free access. And since the students in Uvellas University, if they don't have the access, they always can make the request to the library to get certain set of books or material, whatever they want. So we should turn the table around, that we are proposing projects for them. And then, and in the meantime, if we have a proper platform, and I think the university is capable of doing it very well. And the reason I wanted to come to Uvellas University is in the first place, that to propose to create an institute inside the campus to function like this. That's what we are doing, because we have resources. We have, we can start from the mineral processing. There are, let's say, there are 100 mineral or small and medium mineral processing factories in Sri Lanka. So we are getting the fund to work for those things, and we have enough resources. We have the resource persons like Dr. Chaga, Dr. Titus, or Dr. Amila. They are in the guiding position, and then the students are working for them. And that's exactly what we are doing in some of the projects. We have enough students inside the campus. So sometimes they are on internships, sometimes they are on thesis, but they are working for the real projects. So it is the call of the professors to arrange that with the university, not with the industry, to have the access for them. And for that, we need to have the access to money. Then that is where the funding tools comes in. For example, I told you I'm still working in the UK project. So it is consulting a small and mediums in Northeast Lincolnshire to improve their resources, energy efficiency in their systems. So mainly it is renewable energy, lighting improvements, compressed air, everything. So they don't have any idea, but the community get the funding from the European Development Fund, and they hired us as the consultant. So we are doing the consultancy for the SMEs in that region. Same way we can do that in Sri Lanka as well. But as you told, I don't want to talk about that. That's why I didn't mention the political influence. That is the big and the biggest headache that we have to address. So I don't know how it will handled and how it can be overcome. So I think I'm just talking from this experience, what I have here. So when it comes to Sri Lanka, of course, I know it is not 100% transferable or 100% applicable to the Sri Lankan context. Of course, we need to do some optimization. And I think I gave you the answer, and I forgot to answer one of the questions from Dr. Amila about a key message to the students. I personally have nothing to tell in terms of big things. The only thing that you have to define is who you are. That means you need to identify what are you studying and why am I studying this, okay? And what is the professional goal that you want to achieve in the future. That is the only thing you have to define. Then you can build up your story nicely. So we also had that problem. Okay, we had a lot of subjects in our area, in our student life. So we had the question, okay, who we are going to be. But it's a matter of time. You come to a level that you have to question yourself and ask the question, okay, why I select this degree program. As Dr. Miller told, I got to know him from my cousin. And since that time, 2007, 2009, I wanted to join with the mineral processing and geology. I actually planned to join with the geology in Peradeniya because Dr. Miller and my cousin, they are friends and they were from there. So I had the exposure to that at that level. I have seen how they have gone to mining sites, these things, and Dr. Miller once visited our home as well for one of his research purpose. So I got that exposure at that time. Then that's why I came to Wellas University. So I had that in the beginning. So that is the most important thing, that you have to define what you want to do in your life and what you are doing right now. So it's never been late or something like that. So when you identify where you want to go in the future and what you are doing right now, it's very easy, because if you want to go to a certain professional level, and when you define it with your current status, maybe there are certain things that you don't know in terms of knowledge, then you can identify correctly what is the master's I'm going to do, or do I need to do another degree, or can I do it in another way? So these are really things. Normally, and every year I'm getting calls from colleagues in UWU, the students. They are always asking the wrong questions. Some people asking me, okay, can you give me a thesis where I can go abroad? I don't know what is like that. So it's not our thing to say that I cannot tell that you have to do this. No, it's always depend on you. It is your profile. And normally the key thing that you have to keep in mind is that you have to develop your profile. It has to interconnected to everything. You can do bachelor's as the mineral processing technology. And if you want to go to teaching, that's your thing. But you have to ask the question, do I really need to do a special bachelor's degree which is designed for a specific segment of the country, and do I want to go to teaching? If you want to go to teaching, you should have done it even in earlier without joining the degree. So it's always about defining yourself. You have to identify what you are and who you want to be in the future in terms of professional aspect. That is the only thing that I can say. And we all have problems, financial problems, knowledge-wise, accessibility, or whatsoever. So when you have a clear idea about where you want to go in terms of professionally, it is real easy. That's why I told you that is the hard part, and the solution is real easy. Yes, so I think I answered. So
yeah, thank you, Navoda. I don't want to ask another question, but after your discussion, another question came to my mind. Actually, we have started faculty technology transfer center in our faculty. Now we are trying to take projects from industry and do in our university, then with the help from the students, right? One main problem engaging students on those projects, because we don't have any credit value. If they join the in these projects, we don't give any credit value. Then how the mechanism in Germany now, when they engage those projects, are they connected into education programs, or are they do for their interest?
we have different schemes. First, for example, if I can tell you, that is something I can tell you based on our institute, we have three schemes. First one is that the students can come in and they can say, okay, I have this topic, I have this interest of doing this in this field. So how can I get the help? So then we have my professors in our institute. We will direct them to one of our professors, and then he will modify, because the student came with the interest. So then we don't have any commitment towards him, and pay him or something like that. And when he is there and we modify the topic, which we are getting cheap labor, right? That is one way. The other way is we are publishing.
Navoda.
Yeah. Yes.
Navoda, sorry to disturb. There is a kind of audio problem, I think.
Hear me right now?
Yeah, we hear you, but there is a kind of a mechanical noise adding.
How about now?
Is that same for you, Professor Vitavela?
Is still that noisy is available?
Yes.
Yeah. I think it's from your side now. Can you test the speaker or mic?
How about now? Okay.
Not yet.
Is it okay, sir, if I connect back? Can you hear me now?
Sure. No problem. Yeah, sure, no problem. And until Mr. Navoda getting back, I see that there are many students still in the session, so I would like to request you again, please unmute yourself, or else you can type your question into the chat box. Then you can ask questions directly to Navoda, because I think because we remember, as Professor Vitavela clearly said, we remember he joined the university in 2011. He was a bright student in mineral resource technology. Now he's studying he's following his PhD in Germany. So it's your time. I think it's yours, senior guy. Now that you're back, right?
Yeah. Can you hear me, sir?
Yeah. Now it's clear and audible.
Okay.
You can proceed.
Yeah. So shall I go when I?
Yeah.
Okay. So
Yes, sir.
what I was telling is that we have 3 schemes. One is when a student come with their interest, we direct them to one of our professors in the institute, and he will orient or he will modify the topic into a level that we can get a benefit as well. So that means we are getting cheap labor or labor without pay. Okay. So because the student is come with the interest. And the second one is we publish articles or publish advertisements to hire students. Because, for example, last month we published one for a project in African region based on the water and water management aspects. So we were lacking certain manpower, so we published article advertisement to hire some students. We needed like 2 positions. So then what we did in there is we get some CVs, we evaluate them, and we get the best out of that. And then it is paid. And then the third phase come if we can arrange to a level that if you want to get paid, okay, you have to do a 6-month or 7-month period. That's it. And if he's like to continue it with as a thesis, and if the student like to continue it as a thesis or a publication, then of course there will be a contract with the student. We will pay him, but in a limited way. So, for example, when we are taking him for the total project for like 6 months, and if it is not a thesis, then he will get around 15 to 19 hours per week, which will pay around 800 euros per month based on the university price category. If he's an undergraduate or a master student, the price will be varied. And then the second phase is that, okay, if you want, okay, still this is a contracted small research assistant job, but if you like to continue it as a thesis, then we are paying you maybe half, or we are giving a small contract based on 5 hours per week or something like that, and then he has the chance to work in the thesis. So that's what we are doing. So we have a different approach, and sometimes we also have a signature course called Traveling University, and in 2014 this university was in Uavellas as well. So from that we are giving an exposure to the students in the campus. So yeah, that's what we are doing. And I think if you have enough funds from the budget, so it's also, we have to define what is the budget we have for HEVs or the research assistants in the beginning. And if we run into because most of our projects are running for 2 years, some of them are 6 months, some of them are 3 or 5 years. So we have enough time to plan in the beginning. Do we really need to get research assistants? Normally in everywhere, and if you have seen my first few slides, we have nearly 15 student assistants every month. So they have 3 months contracts, 6 months contracts, depend like that. So we are the leading part. We are taking the role of managing the projects and everything, but we are giving a portion of the budget to the students. That's how we do.
Thank you, Navoda. Now I think students can have some questions.
Yeah, Navoda, there is one question one first year student has raised. I am not going to disclose her name, but she has asked, as a first year student, she would like to ask, how did you do your academic? That's mean, how about your GPA? And she says she would be much grateful to you if you can say something about how we choose our career path correctly.
Yeah, I mean, if they want to really know about my academics, I think Dr. Titus and Dr. Jagat Pitawala is the person who should answer that. And I mean, I was really relax. And the Dr. Jagat also very friendly with us at that time. We played badminton all the time. So we did all the things during the academics. I never only locked into books or something like that. I really don't like to study that much. Don't take these advices from me, but I'm telling about myself. So my GPA is not that much good. I have 2.83 or something like that. And still I managed to get a scholarship because I showed a proper profile to the campus and I showed them as an asset. So that's why they kept me in the full-time employment scheme as well. That is not a motivation for you to reach higher classes or higher GPAs. But I haven't had that, but I know now it will be easy for you to have a higher GPA, and then it will be easy for you to go higher studies and things. But from my experience, as I know in Germany, that they are much practical people, and they not only consider the academics, they take a look on your whole aspect. What is your research trend? What is your professional experience? And what is your academics? Of course, it's important, but that is not the only concern. Based on my experience, they take a look about your practical approach. So I did everything when I was in university. I played badminton for nearly 2 years, and I was the captain for nearly 2 years. From the beginning I played, but I did the captain for 2 years, and we did events like ACES. That was started in my time, and we did a lot of things, and we had a lot of fun during the time. So to select the academic thing, it is not my say, it's your say. It's something you have to define. It's something you have to define it with what you like. So you have to select a path that you can enjoy. And to be honest, I don't like to work in the same thing for all the time. So that's why I selected, and I was very happy to stay here, that we have different projects in different years. And now 3 of them are initiating by next month after the summer break. So I have the chance to go into different industries, different countries. I'm really enjoying that. So that is something you have to define. Do you like to stay in one position, or do you like to engage in different studies? So it can be academic, or it can be industries, whatsoever. So, and also I personally think it's good to keep both hands in one in academics and the other one in the industry. So then you can update your knowledge and you can work in the industry in the same time. Yeah, so selecting the path is not my say, as I told you. It's a decision that you have to make. Yeah. And of course, you also you also can tell the students about how we did back then. Yeah.
And there is another question. It says, what is the path you used to do this PhD? That is, have you got the scholarship?
No, I got the scholarship for my master's. When I applied for my master's in 2017, I got selected for the master's. Now I don't have any scholarship. My scholarship is all over. This PhD is actually my topic. I came up with, and I made the proposal, and I presented it to one of the leading professors in Germany. He's the chair of mining in the Technische University of Freiburg. It's a mining academy. So for the PhD, there's no scholarship, and I don't have any funds at the moment, but I have the access. So PhD is my topic. It's all on myself, and I'm defining what I have to do. I'm finding the people who I can work with. So the supervisors are only to guide me. So master's is the one I got the program that I got the scholarship in 2017. And now it's finished. Yeah. So actually, PhD, and in that time when I applied for PhD, of course, I applied for like nearly 30, 40 openings. Some of them are, to be honest, to practice the apply. But I got selected to 2, but then I asked the question, is that really what I wanted to do? Because some of them are LCA, life cycle assessment, and those are things that I'm using at the moment, but I don't want to get that much into those things because that is not what I want to do. So that's why I came up with my own topic, and I proposed the topic and the proposal to the supervisor. Yeah, it has to be strong when someone has to select you. Even they don't have any commitment towards you. Of course, they have to guide me, and they have to have publications and a lot of commitments. But in reality, they don't have to pay me, or they don't have to share a budget for me. So in that case, they are pretty safe. But still, to get those people into action, you have to have a strong proposal. Yeah.
Okay, Navoda, I think so we are getting close to the end of the webinar, and the last call for our students. If you have any more questions, it's time to raise them.
Yep.
And meantime, Navoda,
Yeah.
I am going to ask a bit personal question.
Yeah.
So I'm going to reveal here now. I still remember the day you joined university. You came in 2011. If I'm correct, you joined the university in 2011, October 5th, I think.
Yeah. Yeah.
So I joined you, let's say, in 2011, 1 week after you joined in October 11. And I still remember where you work for the Grammar at the very first communication skills course. And afterwards, yes, we still remember you started ASS and all, badminton tournament. And what is important here now, we are from the Faculty of Applied Science. At that time, it was the Science Faculty.
Science and Technology,
and since we have many students here now, Uwe gave you the full life, I think. Now we are with Nadi, right?
Nadisha, Chaturi Nadisha, yeah.
Yeah. Chaturi Nadisha, is it okay if I tell you to our students?
Yeah, sure, no worries.
Yeah, okay. Now I have consent. Okay, now Chaturi was one of the bright best students produced by the Faculty of Management. We still remember the way Chaturi worked. And yes, exactly, she was one of the finest students we ever produced, I think, Chaturi. And now Chaturi and Navoda, now you live in Germany. Now, how is your life there?
Yeah, it's a little bit busy. You know that now we have a baby. Yes, now he's turning 2 years. Yeah, he's turning 2 years on this Saturday. So, and she also came here as a student for a scholarship, and she has to skip.
What she's doing?
She's also doing a master's in my university. It's also into management. Right. Yeah. So she has to skip 1 year in her studies. She already finished her all the academic background, and everything is done, but now she has to finish the thesis. So she's taking a little bit off time due to the baby, and yeah, we are doing fine. And the professors and director here, they are very helpful here. So we got a lot of help during that time, because at that time I was a student when we got our baby. Yeah, we all doing fine, and we are hoping we all want to travel to Badulla, but due to the pandemic situation, it's really frustrating, and my parents want to come back. It's also stuck. Yeah, so we are doing all good, thanks. And we have a lot of fun experience during the Glamoro and everything.
And also give a regards to Chaturi, and
yeah,
this open forum, I would like to request I think she's in my Facebook also, but we were talking Navoda, we had to this forum, our students, this is how we manage our relationship now, even though now they have passed out and she's now in Germany, but still we are in Facebook. That's how we get the maximum out of Facebook, I think, because now trend is our new student, the freshers, they always stay with the Android and these smart devices, but I don't know whether they're taking maximum out of this. So this is how we maintain the relationship. So I would like to request now that
Chatur is here.
We would like to have
Chatur is here in the webinar.
Yeah, she's right. Chaturi, is it okay? Can you talk right now?
Yes, I can talk.
Very good. Glad to see you, Chaturi, after a long time.
Yes, after a very long time. I was just listening through YouTube.
Is it?
Yes.
So thank you very much for joining today. Now you have a 2-year kid, right?
Yes, 2 years kid is having a nap. Otherwise, I won't be able to join with you live.
That's great. Yeah. Is he a boy or a girl?
Boy.
Yeah.
Good. I have two. My second daughter is still 2 years old, so I know how we are going to manage this one.
Yeah.
So it's really a pleasure to see you both, Navoda and Chaturi, and especially Chaturi. Now, since you are in the forum, I don't know whether you can manage this one. If you have any free time at your convenience, if you can share your experience in Germany and how you study there, we can have a separate time for another webinar.
Yes, sir. I would be happy to share my experience. Yes, sure.
It will be possible because by the end of next week, I'm going vacation. I'm taking the vacation, so then I can take care of the baby.
That's good. So now they will do the babysitting then Nadisha, Chaturi have enough time to prepare then. Chaturi, I will text you then we will have a short discussion how about what topic we can take this one. So we don't need much technical things, but Navoda, he's expert in the mining field. That's why we went for a kind of technical stuff. But Chaturi, I think you can have a general topic. Then we'll invite our management students as well as tourism students also from the faculty. Then we can have another vital session with you.
Yes, sure, sir. I would be happy to share my experience.
Thank
you. Yeah.
Okay.
That's great. So we have spent, I think, more than 2 hours. So thank you very much from the university side. I would like to thank Mr. Navoda Senanayake, and also we should mention here we had Mr. Christoph Dohm from who is the project manager of energy efficiency and renewable energies for the Institute of Applied Mineral Flow Management, Germany. So he left the session because he was busy. And also we know that Navoda is really busy. And before we moving into the concluding remarks, Navoda, do you have anything to say? Before Navoda, Chaturi, would you like to share something with us?
Navoda, you go ahead.
Okay. No, he asked. Okay. So no, thank you very much for inviting us for the session, and we really like to help. So if any of the students are interested for anything, please let us know, and that's it. And if you need any help in the future, or if you need any input from our side, please let us know. We are really happy to help, and for sure, whenever we are in Sri Lanka next time, we'll be in UWL University, because I mean in terms of work, and we want to see our university, so we'll be there. So yeah, that's all. Thank you very much.
Thank you very much, Navoda. Now we are going to wind up the session, and behalf of the university, I would like to thank Mr. Navoda Senanayake, a proud product of ULS University. Now he is the project manager of Energy and Climate, International Project Management at Institute for Applied Mineral Flow Management in Germany. So thank you very much, Navoda, for spending your valuable time with us. It was a really fruitful session, and you gave us a really informative and also inspiring talk to our students also. And also I would like to mention here Professor Jagat Pitawala, Dean of the Faculty of Applied Sciences, also Dr. Titus Kure, as well as Dr. Amila Sandaruan, who joined the session and enriched the discussion. And also finally, I would like to thank all the students who joined today, and thank you very much for spending your time with us. So we are coming to the end of the session, Faculty of Applied Sciences. Hopefully, I think Dr. Very soon we are going to meet you again with another valuable topic, enrich the discussion series. And also, finally, I would like to thank all the students who joined today and for joining today. And we would like to meet with Chatri also with another valuable webinar like this. Thanks, everyone, and have a nice time. Thank you very much.
Okay, thank you. Bye-bye.
Valuable topic, enrich the discussion series. And also, finally, I would like to thank all the students who joined today and for joining today. And we would like to meet with Chatri also with another valuable webinar like this. Thanks, everyone, and have a nice time. Thank you very much.
Okay, thank you. Bye-bye.